Welcome to this Rhino and Grasshopper basic attractors tutorial with a focus on curve attractors. In this video, we will be using Rhino and Grasshopper to create a pattern of pavers, which are then scaled down based on their distance from a curve drawn in Rhino. There will be adjustable parameters for where to start the scaling down, the fall-off rate for the attractor scaling, and the minimum paver size allowable. In this tutorial, you will also learn how to use the sift and combine components to offset alternating rows of items, how to use the curve closest point component, and how to remap a numeric domain using the bounds and remap components. Let's get started. So we're going to start by drawing a plane in Rhino. So I'm going to come here under the Surfaces subtab and look for this rectangular plane corner to corner component. And we're just going to draw a simple rectangular plane. And then we're going to feed that into Grasshopper with the normal method here under the first tab, parameters, surface. And we'll right click that, set one surface, and we'll set that surface in Rhino. And we're going to hide that. I'm actually doing very similar to in the previous video on multi-point attractors. So if you would like a more detailed explanation of what I'm doing, please refer to that video linked in the description. But I'm just going to come now and come and do an isotrim, surfaces, utilities, isotrim, and I'm going to come here under analysis, math, domain, divide domain squared, to divide that surface domain with u and v values, which I can adjust with sliders. So again, if you want a more detailed explanation of what I'm doing here, please refer to the other video. So I want this initial subdivision to be quite rectangular, something like that, because I'm thinking of these as being pavers on a surface, and in the next step, we are going to offset this. I'm just going to do one last thing. I'm just going to come here under parameters, geometry, and I'm going to find one of these geometry containers which can handle any type of geometry, planes, volumes, surfaces. Turn that off, and I'm just going to flatten that. So now what we want to do is we want to move or offset every other row of our pavers a slight amount, just to give it a staggered joint pattern, which is typical of brick masonry. And to do that, we're going to use a method called sift and combine, which are two components that are found here under the third tab, set, list, sift pattern. And we're just going to go ahead and come back here, and we're going to put our combine after that. So what we want to do is we want to take our list of geometry, and I'm just going to turn that off. And currently there's a pattern 0, 0, 1, 1, which is our sift, and I'm just going to change that to, by dropping a panel down here, 0, 1. Now I need to come up here and right click my panel and make sure I have this multi-line data checked. And I'm going to put that into my sift. So what's this doing? If you saw the previous example, we did a call pattern on, this is essentially a true and a false statement. Now for false, we use the value 0. For true, we use the value 1. And it puts this set of geometry into either this 0 output or this 1 output. So let's see which is in which one. I'm just going to turn this one off. And I'm going to put a geometry container on the canvas, and so we'll see what's coming through our 0 output. So I have all this in the 0 output and all of that in the 1 output. Now, depending on your initial divisions, if your v count is an odd number, you won't get this. So let's just change our v count to 73. And if the v count is 73, we get this kind of checkerboard pattern, which is what we don't want. You'll see why in a minute. So this parameter here needs to be set to an even number for this method to work. So what I might want to do is come here on my v count, double click that, and there is an option with this slider accuracy to set this as to allow only even numbers or only odd numbers. So we want to have this even numbers checked, which will allow us to only spit out even numbers, which will make this particular example work properly. So if you don't have that set, you're going to get results that are different from what you're going to see here. Now, notice I could also come here and do true, false, and I would get the same thing happening on my sift. So true is now going into 1, false is now going into 0. But what sift allows you to do, which dispatch does not allow you to do, is to actually have multiple channels. So you can have a channel 0, channel 1, channel 2, channel 3. So you can essentially dispatch into multiple pathways. So list, pattern, true, false, 0, 1. And so let's just go back to our zeros and ones just so it's clear what's happening there. So what do we want to do is we want to actually, and we're just going to do another geometry container for the 1. Let's just come back here and I'm just going to turn off this initial surface just so that doesn't confuse us. So we have this set of geometry and this set of geometry, and basically what I want to do is just move this set of geometry a certain amount in the x direction. And so to do that, I come here under the transform tab, and it's transform Euclidean move. And what I want to do is just set a value in the x direction. So here under vector, the final tab, unit x. And let's just add a slider to that to give a 1.25 to give a variable amount here. I'm going to turn the preview for that off. And now, if I have 0 movement, you can start to see this offset. Now, I could have it centered in each cell, or I could just have a stagger like that. So this is a way you can start to offset every other course of a particular pattern. And if I come back here to these initial parameters, since I did that U and V properly, I can come back and I can change my pattern of cells. So let's just go back to something a bit more brick-like, rectangular-like in proportions before we continue to the next step. Actually, before we continue to the next step, what we want to do is we want to actually take our two streams and combine them back together. And that's often, doesn't have to be, but often we use sift together with combine. So here again, under list, set list, combine data. So we could take channel 0 and channel 1, and I'm just going to turn the previews for those off. And now we have, turn that off, and I'm just going to put a parameter of geometry and put that on the canvas and feed that in. So now we have everything back as it was in the beginning. So we only separated every other row just for that purpose of doing that movement, and then we combine them back together. So now we're going to get to the core part of this example, and we're going to start setting up our curve attractor. So I'm going to come here. All I have turned on right now is my geometry, my individual pavers. Everything else, the preview has been turned off. And I'm going to come back here into the Rhino window, and I'm going to draw the curve or the path that I'm going to use as my attractor. So let's just use this tool, the control point curve, and I'm just going to draw curve, something like that. It doesn't have to look exactly like that, but something like that. So we've drawn this curve in Rhino, and now we want to feed that into Grasshopper. So I come back here to the first tab, Parameter, Geometry, Curve, drop that onto the canvas, right-click that, set one curve, and now that has been input into Grasshopper. We're going to come back here into Rhino, and I'm just going to hide the geometry. And so now we can just only see the geometry, which is in Grasshopper. So our pavers, I'm actually going to come here, select that, right-click that, and make that a group. And I'm just going to label that pavers. And I'm going to select that, right-click that, make that a group, select the group, right-click, and I'm going to call this my attractor curve, just to help me keep things clean and orderly. So if you watch the point attractor video, you'll know that a point attractor, multiple point attractors, you use the closest point component to find the distance between an object and the object, which is the attractor object. So, and that was found here under under vector point, closest point. So there is also a component, curve closest point. So that's under the next tab, curve, analysis, and this is the component we're going to be using, curve closest point. So we're going to select that, and now we have two components here. P is the point to project onto curve, and C, which is the curve to project onto. So we don't have points, we only have surfaces. So we want to basically find the center point of each one of our pavers and use that as a point to use for our P input. So I'm going to double click, type area, which will bring up my area component. And so I'm getting the area of each one of my pavers. And the C output is the center of each paver, and I'm going to use that as my P input on the curve closest point. And the C input is obviously going to be my attractor curve. And so what that's doing, similarly to the curve closest point components, it's measuring the distance. Well, first of all, it's projecting each one of these center points onto the curve. And you don't have to do this step, but if you want to see what's going on, you can drop a line component onto the canvas. And you can use those center points for the input A, and the P output from your curve closest point component will show those actual points. So those are the points that we're measuring to. These are the points we're measuring from, and the line, the distance, is being extrapolated from the length of this particular line, and that is coming into our D output here. So let's get rid of those lines. It's a bit messy, but that's what's going on. So it is measuring the distance from this center point to here, and it's basically finding the shortest path between each center point and that particular attractor curve. And that's giving us a value here under the D output. And that's what we want to use, what we're going to use. And let's just look at what those distances are in the next step, where we're going to start to scale our pavers down. So now we get to the heart, the meat of this script, the fun part, or the headache-inducing part, depending on your perspective. If you watch the previous videos on single-point attractors or multi-point attractors, you know that we used our distance to set a radius for circles. So we are going to be using the distances coming out of our curve closest point to be scaling down our pavers. I'm going to actually skip ahead. If you've looked at the written description on the blog, this will be slightly different, but I think this will help explain it maybe a bit better. because what we're going to be doing is, if you find a component here under transforms, the scale component, it's the first one here under refine. So what we're going to be doing is we're going to be scaling these pavers down. So let's find the geometry we want to scale. So there are three inputs for scale. There's the geometry. So that's our pavers. Now they went here because currently they're being scaled around the 0, 0, the world center. So the second input we absolutely need is the center point. So we're going to use the center points of our pavers as the second one. So now they are scaling down. And the third input is the one we're interested in, which is this scaling factor. So currently they're all being scaled by a factor of 0.5. And so that is what we're going to be focusing on for the rest of this example, is ways to get this scaling factor, something that is related to this distance output from curve closest component. Now, if I just drop a panel down onto the canvas, I'm just going to type panel, and I look at my distances. Currently, I have numbers 91, 50, 68. So these numbers, if I put those in for the factor, are going to really just not work. Now, I could divide these by maybe by 100 or something and use those somehow. But what we really want to do is we want to see what is the range of numbers that we're getting for distances, and this will actually come in handy for the logic of our script in a minute. So here under the second tab under Maths Domain, so domain is a range of numbers between two different values. The third component here is the bounds component. I'm going to drop the bounds component, and I'm going to put my distances into the bounds component. And I shouldn't have deleted the panel I had there. I'm just going to put that back. So I'm going to add a panel here, which is basically saying the bounds of my distances. The distances are, the smallest distance is 0.0659, blah, blah, blah. The highest distance is 123.86. So those are the current bounds, the lowest and the highest value. And what I want to do is I want to remap those numbers. So remap that domain to a series of values between 0 and 1 initially. So I'm going to use domain remap numbers. This requires three inputs: a value, a source domain, and a target domain. So the values I want to remap are my distances. So I want to make all my distances be a number between 0 and 1. So that goes into the V input. Source, that's my source domain. Luckily, we already have the source domain, which is basically the range of numbers that are in the distances currently. So I'm just going to put that in for source. And then target is the domain I want to remap those to. So instead of the distances being numbers between 0.06 and 123, they're now going to be numbers between 0 and 1. So I'm going to take the result of that, these remap numbers, and if I put that into my panel, I can now see 0.74. I have a series of numbers between 0 and 1 based on my distances. We will be changing this value later, so don't worry about that. But for now, I'm just going to take this input and just drop that into F to see what happens. It turned red, which means an error is being generated. And if I look into that, it says you cannot scale with factor 0. And that's because I have at least one value in this list that is 0, because I remapped, basically I remapped, I keep deleting this panel, I shouldn't delete it. I remapped that 0.06 number to 0. So one of the ways to get rid of that error message is to have my target domain be from 0.001 to 1. for example. Currently, it's not a problem, though. It is actually scaling these, and we'll solve the problem later by other means. But what you can see here is we already have the logic of our attractor kind of going. I'm going to turn off the preview here, where it's actually the opposite of what we really want, which is that the closer you are to this curve, we want the pavers to be bigger, and we want them to get smaller as you move away. So the easy fix to that, which will start to introduce our next step, is to flip our domain or to subtract it from 1. So currently we have values between 0 and 1, and now we want to use the subtract component. So here under maths, operators, subtraction, and we are going to just have a panel with the value 1. To get a panel with a value of 1, you can just type double quotes 1. And what we're going to do is subtract 1 minus that. And now that will flip, in essence, our domain. Now, so we already are starting to get close to the logic we want. We still have this error message generated. Don't worry about that for now. But I don't want my pavers to start scaling down immediately. I want them to basically be full size and up to a certain point and then start scaling down. So one of the things I can do is I can, instead of having this one here, I'm going to add a slider. So double click, and I'm just going to type 1.25, which will give me a slider between 0 and 10 with 2 decimal points of precision. I actually want my maximum value here to be 2. So let me just change that now. And so now you can see, if I play with that, I'm starting to get values now between 1.32 and my floor. So this is starting to get to where I want, but basically I don't want any pavers to be scaled up. So currently, some of the pavers are going up by 1.25 in my scale factor. To solve that, we just need a simple minimum component. So here under maths, utilities, minimum. And basically, I want a little update coming up. Basically, I want my minimum value to be 1. Sorry, maximum value to be 1. And to get maximum value, use the minimum component. So this will basically return the smaller of 2 values. So either this scale factor or 1. So 1 will be our ceiling. So we'll feed that in instead to this particular component. So now I am starting to get, as I increase my slider, you can see that the width of that surface, which is continuous or not scaled down, is increasing. So now what we're going to do is we're going to come back here and we're going to play around with this target domain value. So what that will allow me to do is set the kind of rate at which these are scaling down. So currently, the furthest away objects have the smallest factor, but maybe I want the smallest factor to be a bit closer to my path. So what I could do here is the target domain is currently between 0 and 1. I can just drop a simple slider into there. I'm actually just going to copy this one. Control C, Control V, and I'm going to put this slider in here, which will basically, now my numbers are being remapped between 0 and 2. And you can see here, this is the smallest, but then it actually they start to get bigger again, because basically it's in negative territory now, and a negative scale will actually basically start to scale it up, if that makes sense. We'll get to that in just a minute. We'll fix that problem in just a minute. But by changing this target domain, I can adjust the rate at which these change. I'm going to come in here, double click this. I'll make the maximum, this can be 3, which will allow me to have that scaling off a bit faster. So I'm going to rename this to scale fall off rate. And I'm going to name this parameter to scale start factor. So I have two parameters here. Where the pavers will start scaling, I can increase the width of that or decrease the width of that. And then the fall off rate. So I don't want basically these negative numbers to be scaling up. So I'm going to add one more component after this minimum, which will be a maximum component. And so here under utilities, maximum. And basically I want our maximum, the greater of A and B. So basically I want this to be essentially 0. And we can't scale by 0, so I'm just going to do double quotes 0.001. And that will be the maximum value, and I'm going to input that. So basically I've gotten rid of all those negative values, and now my pavers are scaling down properly. So I can change that fall off rate, where it starts. And so this is the kind of the gradient area is between where it starts, the start factor, and then where it ends. And I have this maximum 0.01 to get rid of it. Now, in real life, you're not going to have this really small paver. So I'm going to do one last thing after the scale is I'm going to do a call pattern based on the size of these. If you want to see this set up in detail, look at the multi-point attractor example, but here I'm going to go under set sequence call pattern, and I'm going to basically call the outputs there, and the pattern will be based on the area. So the area of my pavers, I'm going to get those, and if it is larger than I'm just going to put a random number here, 0.2, it will be gotten rid of. So let's turn the preview of that off. Sorry, I put the wrong one in. It's not the center point I need to put in, it's the area. So going into this larger. So that will get rid of now. You can see as I start to increase that, it will change, and I'm going to make this have a maximum of 10. You can see where those smaller pavers are starting to be gotten rid of. So we have 3 controls now, and this will be, we're going to rename that as smallest paver area. And so those are our 3 controls, and I'm just going to put those into a group. I'm going to color that group red, and I'm going to call this my curve attractor controls. Now what we do after this, we could use the custom preview to give those a color. It's not something I'm going to do in this particular example. You can look at some of the other videos to see how to do that if you don't know how to do that yet. But that is the basic logic of the curve attractor. Now I can now come back, let me just come back and turn off this curve closest points component. And now I can come back and I can show my curve in Rhino. Sorry, let's hide that. And I can come in here and edit the control points. Turn those on, and I can, whoops, start to move my curve attractor around. Let's just use the gumball to move these points up and down. And you can see that once I have the curve attractor working, then I can start to do this. Now, what if you want to have a path going off into this direction? I don't think as it's currently set off, you can have multiple curves, but you can have, let's just change our curve to this. You could have something like this, which will allow us to have a forked path. And I'm going to come back in and set that as my attractor curve instead. So you can have a path which is a bit more complex to start to make intersections and areas, etc., where the curve is working. So you can play around with that once you have it set up to your heart's content. And so this is a bit of a wider area. And so basically how you draw that initial curve is what kind of gives you a little bit of creativity that you can do in how you deploy your curve attractor. So hopefully you found that useful and helpful, and thanks for watching. If you would like access to a completed Grasshopper script for this example, as explained in the video, you can come download this from generativelandscapes.com, my website, which is linked in the description, for a small fee. Included is the version as described in the blog, a version, slightly edited version as described in the video with adjustable fall off, along with 2 other Attractors scripts. So if you would like to support me and this channel, please head over there and download it. It would be much appreciated. Thanks for watching.